Well, welcome everyone. Thank you for having me here to talk to you. I want to thank Jerry for giving us a grade, and there's no grade inflation in what he gave. I think it's a little lower than what I would have given, but um, we all want to be happy. We all want to be, fulfilled. And I want to recall one of my former students and later professor, Dr. Jun Liu, who passed away last year, unfortunately. And he was part of our community, and that's why I want to also ask at least a raise of hands by University of Alabama colleagues to just recognize the memory of Jun Liu. So his students, former students are here, and I really appreciate that. Okay, so what we tried to do in this project, and I'll try to give you a sense of where we are. So the urban solutions may not work in rural areas. One size fits all doesn't quite work necessarily like in the rural areas, because the reality might be different. It is different. We know that there's infrastructure gaps. There's also cultural differences. Communities in rural areas are distinct in terms of how they depend on each other for mobility, for other services, healthcare, so on. There's also institutional challenges, like we have a system where we have the RPOs, which are kind of equivalent to the MPOs, the Metropolitan Planning Organizations. So we have rural planning organizations, but they are under-resourced. And that's a big issue. Also, there are data deserts. Like, we just don't have the amount of data that might be needed for the system to function. As we know, data is the glue that is enabling automation, all these new ideas, AI. So when you don't have access to the data, or you don't have the infrastructure to have that data, that becomes a problem. So what we are trying to do is to look for solutions that might be applicable, innovative solutions that might be applicable, and where we can leapfrog the rural areas in terms of within rural areas, to establish test beds and leapfrog. Like we did with landlines, we have now cell phones. So that's the basic idea of this whole project. Let me see if I can play a video that thankfully Ali had helped us create. And there is a bit of a lag. I'm not, okay, one more click.
Once, roads were filled with steam and carriages. Every trip from one point to another took hours, sometimes days. Today, the world moves at a different pace. Self-driving cars, automated shuttles, and other advanced technologies are emerging, aiming to shorten distances and transform daily life. Yet one question remains: are all communities, especially rural areas, ready for this transformation?
We need to make sure rural communities are not left behind as new technologies roll out. Tools like automated vehicles can bring real benefits, but they're not a one-size-fits-all solution.
Before using any new technology, we must understand whether a region is ready to adopt it. That's why a team of researchers from the Center for Regional and Rural Connected Communities has developed a set of innovative tools to assess technology readiness. This toolkit is called TACT-R, which stands for Techniques for Assessing Community Technology Readiness.
We designed the tool with user-friendly interfaces so that people from different technical backgrounds could use the tool with confidence. TACT-R uses artificial intelligence as well as data from similar projects to guide decision-making.
But understanding readiness isn't just about having data. It's also about learning from what has worked before.
Suppose we have a project considering automated shuttles in rural areas. TACT-R provides information from similar cases in the past and lessons learned.
Those insights guide planners and communities from concepts on paper to real-world solutions, helping them plan smarter and avoid costly mistakes.
With just a few clicks, you can check the infrastructure and operational needs for the deployment of automated vehicles. That way, planners know what's already in place and what still needs work. It also highlights where physical and digital infrastructure are lacking, so organizations know exactly where to invest first.
By pinpointing exactly where communities are prepared and where they need improvements, TACT-R moves beyond theory to deliver actionable, location-specific insights.
We used this tool in North Carolina, and the results were insightful. Using geospatial analysis, we were able to derive county-level to block group-level readiness scores that can help agencies like DOTs plan and adopt for autonomous vehicles in the future.
We also use this tool in Florida. Story maps have revealed where the infrastructure is strong and where more investment is needed, such as in road improvements and broadband expansion, just to prepare for autonomous vehicles.
TACT-R can be applied to other areas across the Southeast, enabling better data, better decisions, and more effective outcomes when adopting emerging technologies.
We invite planners and researchers to visit the CR2C2 website and make use of our TACT-R tool for their planning and assessment of future transportation technologies.
TACT-R is an ongoing effort to prepare communities to become more prepared for the future technologies based on accurate data and efficient decisions.
All right, thank you so much. That I can actually walk away right now, but I'll go through the rest of my presentation. So Ali, again, thank you to you and your team. Okay, so basically what we are trying to do is to take out the guesswork and do some systematic assessment of what is implementable, what is not. And for that, we developed a structure, a framework, so to speak, and we successfully evaluated solutions which include AI, rural ITS, automated shuttles, as well as broadband connectivity. And I do want to recognize my colleagues' contributions, as you saw, Sudagar and also Venkatesh in the video. So they have a tremendous contribution to us in this project. So the project envisions like a data and knowledge base where you have sensors, rules, text base, which is information coming in. And then we have also goals and performance measures like mobility, safety, hotspots, finding difficult places where people cannot navigate. We also have strategies and actions like we mentioned, automation, so on. And then analysis tools like we were showing you, case-based reasoning is one of them. And all of this to put it together within the context where we are looking at stakeholders and trying to see there are so many of them, they have different opinions about what is going to work, what's not going to work, and then there's some level of experimentation that takes place when we do use new technology, untested technology. So this is the more deeper view, which I won't go through the details of, and there is a mathematical model that I've been trying to develop for many years now. But basically, this is there's a much deeper framework that embeds this whole idea of TACT-R tool that we are developing. So I'll show you the practical aspects. It is based on text mining and case-based reasoning. It analyzes unstructured data, and also it focuses on automated shuttles, at least at this stage, and also adaptive signals. So the basic idea is that the planner has some background information that they need in order to implement innovations. So they and make informed decisions. So they try to go to through this text mining, and now with GPT and so on, these tools have become available, and they come up with possible solutions. Also, that results in maybe some assessment of readiness. Are we ready? Can we implement automated shuttles? They cannot be just put onto the road without having proper infrastructure. So we come up with feasible solutions for planners that then can look into it in more deeper sense, and then they can look at historical cases. Has automated shuttle been successful in other contexts like similar cases? And you can come up with candidate solutions as well as the finalized solution after doing benefit cost analysis. So readiness is a key part of this whole thing, but the whole process starts much, much earlier and is supported by, in this tool at least, we envisioned it to be supported by emerging technologies. And it involves spatial analysis, as Sudhakar was mentioning, story maps being one of them. But it's pretty deep analysis of how we can come up with solutions and assess their impacts. But idea is to make informed decisions. This is just the tool a webpage that you can go to, and as on the top, there are these several menus which can go through the different ideas that I just presented, looking at maybe initial solutions, then getting deeper into the tools, the case-based reasoning tool, and then we thought about expert systems and digital twin as well, adding that level of tooling. This is the integration that I wanted to mention about how our partners work together with us into looking at North Carolina broadband data, Florida geospatial data set, as well as the US duties communities data set, and then use cases from the literature, as well as project reports. And we put them all together in this tool, case-based reasoning, which works really simply. Like if you are thinking about some challenges that are facing the community, rural community, is it ready for a level 4 or level 5 automation? Level 4 is more like robo-taxis that we see now by Waymo. So the goal is to identify safe routes and test handoff scenarios where some problem happens, and does the system, how does it hand off control to a remote driver or a driver within the shuttle. But basically, you're looking at how this autonomous shuttle can be implemented within the rural context. And what we tried to do was to develop this case-based reasoning, which matches a planned project to the most similar past deployments, and it ranks it by similarity, similar to your context in which you are operating. So as on the left-hand side, you can see if, let's say, I select, okay, I want to look at a beep shuttle. Of course, I would have had some knowledge of what kinds of different shuttles might exist, and you want to select maximum speed of that shuttle. Is it a fixed route or not, and so on. So once you submit that information, the workflow is that you get the user gets information about what are the different similar cases, the most similar one to your area, for example, in terms of population or in terms of other infrastructure. This is the most similar case, and one can get into more detail on what are those top matches, showing us what were the problems that they encountered, what were the lessons learned. So So really, stakeholders can understand at depth what happened in those cases. Additional tools have been developed in terms of car sharing and adaptive traffic signal control by one of our really good student. His name is Usman, and Sheikh Usman has graduated now. He's a doctor, Usman, and he's moving to Connecticut, I think, to the Transportation Institute there. So the readiness assessment is another tool that we developed where you input information about the regulatory and legal framework, and we give it a weight, and infrastructure readiness as well. Does the shuttle, for example, operate on fixed routes or not? Okay, I have 3 minutes to go, so I'm going to fast forward. You input quite a lot of information, but in the end, it gives you the score of readiness, and it identifies whether you have the operational capacity or the infrastructure readiness and so on. So the so what question is whether, well, before this TechDAR tool, a rural community would have, maybe invested in an automated shuttle, like let's say $2 million, and it didn't work because there were connectivity dead zones and it was not able to operate well with a remote driver, for example. But the readiness tool flags this kind of issue, and it says, well, your critical gap is that you don't have the digital infrastructure which is really needed. So in addition, NCANT provided this tool with Venkatesh giving us a readiness tool, which we presented at TRB. This paper has been published in TRR, so we're really happy with that outcome, and it provides in North Carolina the readiness. Similarly, FAU helped us with these AV readiness in rural Florida. As you can see, automation and electrification being a key theme, and where there are deserts and where there are opportunities. So the communication tools are also being developed. These are AI-assisted knowledge synthesis workflows that we are developing. And I just will skip that and just get to the conclusion part, where we think our key contributions are that it's a first-of-a-kind platform for rural technology readiness assessment. It has AI-powered tools, case-based reasoning, readiness scoring, spatial analytics, and also its adaptable framework for various technologies, which include AV and also car share traffic signals, which I don't have time to go into details of. And actionable recommendations are that we should at least adopt this kind of approach to in a standard planning tool for rural areas, RPOs in particular, and prioritize digital infrastructure, maybe broadband investments, as well as enabling technologies, and invest in our workforce development and community engagement before technology rollouts. We are looking at additional digital twin creation and AI. And Usman Ahmed is here, and he's helping us with that, as well as Kentucky and the ANT and FAU team. So that's our planned addition to this. So I want to thank everyone in this list for their contributions, and it's been a pleasure to work on this project.